Hi everyone, we're evaluating inverse trig functions in section 4.7. Remember that for this Big Daddy sine function, the inputs are basically angles and the outputs are basically sine values, numbers between -1 and +1. But for the inverse sine function, the inputs are sine values and the outputs can be thought of as angles. By the way, the outputs of these inverse trig functions should technically be written in radian measure or as real numbers. Later on, when we do applications, we may write these in degrees, like 90 degrees. Again, why is the arcsine or inverse sine of 1 equal to pi over 2? When we input 1 here into inverse sine, why is the output pi over 2? For two reasons. Because sine of pi over 2 is 1. Remember, we have the switching between inputs and outputs for the inverse statement. And because pi over 2 is in the range of the inverse sine function. That's really critical. Functions can only output values in their ranges. So once again, if you are asked to evaluate the inverse sine of 1 or the arcsine of 1, how would you go about doing that? You could think of it as a kind of box method, like when we did logs in chapter 3. The inverse sine of 1 is what? Answer in the box there. Right. Well, the sine of what is 1? The sine of what is 1? Remember when we went to from log form to exponential form? The sine of what is 1? It's like a zigzag. Now, a student might say, well, wait a minute. There are infinitely many angles that will work. Think about the graph of y equals sine of x. By the way, on Desmos, if you use the wrench here, not only can you use projector mode to make things clearer, but on the x-axis, you can use a step size of, say, pi over 2 or some fraction of pi in order to get these kinds of values as tick marks. All right, y equals sine of x. We want to know for what angles will the sine value be 1? Well, sine of pi over 2 is 1, but also sine of 5 pi over 2 is 1, sine pi of 9 pi over 2 is 1, sine of -3 pi over 2 is 1. There are infinitely many angles whose sine value is 1. But remember, we're restricting the sine function to this restricted domain from -pi over 2 to pi over 2. We're only supposed to consider this piece of the sine wave, only the piece from this point, -pi over 2, -1, to this point, pi over 2, 1. And if you look at this red piece over here, of these various angle measures for x, the only angle whose sine value is 1 is pi over 2. So we have to fill in this box with pi over 2. Because that's in the restricted domain. So the answer here is pi over 2. A faster way of seeing that is if you look directly at the inverse sine function. Here's a graph of the inverse sine function. What is the inverse sine of 1? The answer, the output, is pi over 2, the y-coordinate of this point. The inverse sine of 1 is pi over 2. Y equals arcsine of x. The inverse sine of 1 is pi over 2. Why? Because pi over 2 is in the range of the inverse sine function. So again, even though it's true that sine of pi over 2, 5 pi over 2, and so forth, even though there are infinitely many angles whose sine value is 1, there is only one angle whose sine value is 1 and that is in the range of the inverse sine function. Pi over 2. 5 pi over 2 is not in the range. If you say that the answer to this is 5 pi over 2, that's no credit. because you do not know the range of the inverse sine function, or you don't know that a function is only allowed to spit out outputs in its range, and that's bad either way. The inverse sine of 1 is pi over 2. It's not 5 pi over 2. You have to keep the range in mind. That's why we kept hitting that theme like in previous videos. We'll do some more examples in the next video.